So what I'd like to do now is do example 4, where I'm going to utilize the technology that we have available to us to help us. And it says compare the percent of Miss Apple's DRP students scoring that falls within a 1, 2, 3, 4, and 5 standard deviations of the mean with the percent guaranteed by Chebyshev's inequality. So to do that, what I'm going to do is I'm going to actually get a z-score for every single one of those data points in both Class A, Class B, and also in the total of all of the students. And to do that, it's pretty easy if we use our calculator. So I'm going to come over here. This is where we left off from the last video. You'll notice that I have my one variable statistics. Now I added 3 more columns at the end here. I added a z-score for A, so z-score A I called it, z-score B, and z-score all. So this is where I'm going to get that's where I'm going to put my z-scores for each of those different scores. So in other words, in this cell right here, the z-score for this student from Class A will appear. Okay, so that's how that's going to work. Now I don't have to do it. I don't have to write a formula for every single one of these. That we can utilize the power of the calculator to help you do that. So what I'm going to do is I'm going to go into this gray cell and I'm going to put in equals. And what I want to do is I want to utilize that formula we know about z-scores. So that means I want to take the 14 minus the 32.6 divided by the standard deviation, which is this 11.6. Well, I don't want to have to do that for each one of them, so I'm going to use what I know about spreadsheets to help me do that. So really what I'm going to do is I'm going to take column A, so I'm just going to put an A in, and then I'm going to subtract from that the value of this cell. So I'm just going to click on that cell, or I'm going to type in F1. Either way works. Okay? Oh, I'm sorry, F2, not F1. Sorry. And then I'm going to hit enter so that it records that, and then I need to put that stuff in parentheses. Okay? Then I'm going to divide that by the standard deviation. Well, the standard deviation is in this cell right here, so instead of typing that 11.6, I'm just going to always refer to that cell. So I'm going to click on that cell, and I'm going to hit enter on that as well. So you'll see down here, here's the formula. I have column A minus that F2 value divided by that standard deviation value. Okay? Now if I hit enter, what it's going to do is it's going to give me the z-score for every single one of Class A or Miss Apple's students. Okay? Now we can do the exact same thing over for these other 2 columns. I'm going to do this next one, and then I'll leave the third one to you, but it's the exact same process. I'm going to go ahead and I'm going to take B minus, but now instead of taking this value of x bar, I'm going to take this one, G2, enter. I need to put it in parentheses, divided by the standard deviation, which is going to be this value right here. Hit enter. And now I'm going to hit enter again, and there are the z-scores for Mr. B's class. See if you can pause the video and do the exact same thing for all students, the third column that we have there. Right, so I did the formula for the third column there for all students. You can see the formula down at the bottom here, and you can check your numbers, see if they're matching with mine as well. So now we have a z-score for every single individual, whether it's in each individual class or in all classes, and we can see where they are relative to the mean for each of those different distributions. Now, in relation to the actual question that was being asked, and that was how many scores fall within 1, 2, 3, 4, and 5 standard deviations. I'm not going to go through everything on that. I just want to kind of show you how we would do that now. So if I'm going to go to Class A, which is all of these z values, you'll notice that if I'm looking with one standard deviation, I'm looking from -1 to 1, so I would just count those up. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and that's it. So that means 15 of them are within one standard deviation, so 15 of the 22 would be within one standard deviation. Within 2 standard deviations, I would add all the ones that go up to 2. Well, it turns out that all of them are within 2 standard deviations. So remember that Chebyshev's what he's saying is that at least that much. So we said at least 0% within one standard deviation, but really we had 15 out of 22. So it was much higher than 0%, obviously, and same within 2 standard deviations as well. So you could do the same thing with each of the different distributions there and see how they relate to Chebyshev's inequality.